Okay, geometry fans, our topic for today is similar solids, so similar three-dimensional figures. Let me tell you your joke of the day. Did you hear about the time traveler who was still hungry after his last bite? Well, he went back for seconds. 4 seconds. All right, so what we're going to talk about, now we've looked at two-dimensional figures that are similar, and what we're going to look at today is, okay, so what happens with areas? What happens with volumes if it's three-dimensional? What's the relationship? So to start, in example number 1, we're going to look at two squares. Find the area of both squares. Well, area is the base times the height, or the length times the width, in this case 2 and 2. So the area is 2 times 2, which is 4. And then this area would be 3 times 3, which is 9. Now, there's actually two ratios that we're going to write down here. The first one is called the ratio of distance. Ratio of distance. Now, distances, that could be length, it could be width, it could be height, it could be a perimeter, a circumference, a radius, any kind of length. The ratio of distance in this problem for the small figure to the big figure is 2 to 3. So that's a 2 to 3 ratio. Now the ratio of distance, I just call that D. The other ratio, though, is the ratio of area. Now the ratio of area is going to be comparing the ratios for the small square to the big square. Now that's not 2 to 3, that's 4 to 9. And you might think, well, wait a minute, aren't those the same? If I look at a ratio as a fraction, 2 to 3, 2 divided by 3 is 0.6 repeating, 4 divided by 9 is 0.4 repeating. So that is a different ratio. So there is a relationship, though. I want you to notice that 4 and 9 are both perfect squares. 4 is 2 squared, and then 9 is 3 squared. So the ratio of distance is 2 to 3. The ratio of area is 2 squared to 3 squared. And I'm going to call that A for the ratio of area. So let's look at the two circles now. Same thing, find the area of both circles, leave in terms of pi. First of all, the distance ratio would be the radii, which is 4 and 5. So distance is in a 4 to 5 ratio. Now the area of a circle is pi times radius squared. So if we take the radius, which is 4, and square it, we get 16 pi. So this area is 16 times pi. That's pi times 4 squared. And this would be pi times 5 squared. Okay, I'll write this one out. 5 squared is 25 times pi. Area is 25 pi. Now you might be asking, well, why don't we get the decimal approximation for that? We could do 16 times 3.14, but when I want to compare the two areas from the small figure to the big figure, I'm going to use 16 pi and 25 pi. If I write the ratio as a fraction, 16 pi over 25 pi, what happens, pi divided by pi is 1, and what we get is the fraction 16 over 25. Now, you always want to make sure that your fractions are reduced. So 16 divided by 25 is 0.64, but if I change that back to a fraction, I get 16 over 25. So the ratio of area is 16 to 25. That is not the same as the ratio of distance. These are different values. However, 16 and 25 are the same as 4 squared and 5 squared. So what you want to notice here is that if you take your distance ratio and you square those numbers, that gives you the ratio of the areas. And this is only if they're similar figures. Circles are always similar to each other. Squares are always similar to each other. So that's for area. What happens when we talk about volume? Find the volume of both cubes. Volume is length times width times height. So for the small cube, 2 times 2 times 2 is actually 8. Volume is 8. 3 times 3 times 3, the volume is 27. Now, the ratio of distance, which I'll label with a D, that would be 2 to 3. The distances, those would be the two lengths, or the two widths, or the two heights. Notice that they're always 2 to 3 in this problem. The ratio of volume, which I will label with a V, that's 8 to 27. That's not the same as 2 to 3. However, 8 is a perfect cube. That's 2 raised to the third power, and 27 is 3 raised to the third power. So what happens here, what I want to point out to you is that volume is three-dimensional, and notice that it would be the distance ratio to the third power. When you talk about area, area is two-dimensional. So area is the distance ratio to the second power. So if we do the same thing with the cylinders, volume is pi r squared times h. So in this case, volume is pi times 4 squared times 8. And if we work that out, what we would get is 128 pi. And then this would be volume is pi times 5 squared, 25, times 10, which is 250 pi. Okay, so on the side here, the distance ratio is, if I look at the radius for the radii 4 and 5, that's a 4 to 5 ratio. Now you might say, well, Mr. Cavell, what about, hey, look at the heights. This is 8 and this is 10. Is that different from 4 over 5? Well, if you think about a fraction, 8 over 10, you can divide each of these by 2 to reduce it, and what you get is 4 over 5. So what happens is that each length or height, each distance is still proportional. The distance ratio is 4 to 5. The volume ratio is 128 pi to 250 pi. But what I'm going to do on the side here is think of this as a fraction. I'm going to reduce it first. You can divide out the pi's, that's just 1. You can divide each of these by 2, and what you get is 64 and 125. And what you may realize is that 64 is also a perfect cube, it's 4 to the third, and 125 is a perfect cube, that is 5 to the third. So what happens here is we're going to come up with this pattern. And the pattern, we're going to write it down here. Ratio of distance, D. Ratio of area is A. Ratio of volume is V. The ratio of distance, I'm going to write that as A to B. A colon B. A and B are just two numbers. Now again, distance could be length, width, height, radius, diameter, perimeter, altitude, circumference. Those are all distances, so that's A to B. If you know that, if you want the ratio of the areas, so like lateral area, surface area, you take these two numbers, whatever they are, and you square them. And it's A squared to B squared. If you want the ratio of the volumes, you take the distance ratio and you raise it to the third power. A to the third, B to the third. Now what we'll do here is I'm going to come over on the side here. I'm going to put a couple examples. And then we'll talk about, all right, how do we move in these ratios here? So example, we're going to do 3 of them. What if I tell you the distance ratio is 2 to 5? Okay, that's your D. We want to find area and we want to find volume. Well, what we can do here is we're going to take the distance ratio. How do I go from the distance ratio to the area ratio? I take A and I square it. I take B and I square it. So I take my two numbers and I square them. I raise them to the second power. So this right here, 2 to 5, what I'm going to do is do 2 squared to 5 squared, which becomes 4 and 25. Okay, so that would be my ratio of area right there. How do I go from distance ratio to volume? So to go from A to B, to A cubed to B cubed, what I'm going to do is I'm going to cube both of my numbers, A to the third, B to the third. So I'm going to take the 2, I'm going to raise it to the third power. I'm going to take 5, I'm going to raise it to the third power. So 2 to the third, that's 2 times 2 times 2, but I can also do 2 and then use my exponent button there. 2 to the third is 8, and 5 to the third is 125. So this is 8 and 125. That's my ratio of area, that's my ratio of volume. Okay, so there's the first example. Second example, what happens this time if I tell you that the ratio of area, what if I give you the ratio of area is 16 to 49? So this time we're going to start with the area ratio. Well, if we're starting with a squared to b squared, the question is, how do you get back to a to b? How do I undo a square? What I have to do is I square root both sides. To go from a squared to a, we square root. So to go back from 16 and 49, I'm going to take the square root of 16 and the square root of 49, and what we get is 4 and 7. That would be the ratio of distance. How do we go from distance ratio to volume ratio? You take your distance ratio. To get to a cubed, b cubed, you have to raise it to the third. So I'm going to take 4 and 7, and I'm going to raise that to the third power. So 4 to the third, 7 to the third. 4 cubed is actually 64. And then 7 cubed is 343. And those are my two answers. One more example here. So let's say this time, what if they give you the ratio of volume? What if they tell us the volume ratio is 125 to 729? So this is where you're starting. What you want to do first is you want to go back to distance. If you don't have the distance ratio, you get it first. So to go back to the distance ratio, I'm here at a to the third, b to the third. To go back to a to b, I take the cube root of both numbers. How do I undo a cube? I take the cube root. So I'm going to do cube root of 125, cube root of 729. Now on the calculator, I can do this. If I go to math, and then number 4, which says cube root. So the cube root of 125 is 5, and then the cube root of 729 is 9. So we've got 5 to 9, that is the ratio of distance. I want the area ratio. So once I get distance ratio, how do I go to a squared, b squared? I have to square both numbers. So I would square the 5, which I get 25. I would square the 9, 9 squared is 81. And those are my answers. Okay, so let's do example 5. What I'd like you to do is actually shut the video down for a second, hit pause. Can you fill out these tables? Okay, fill them out on your own and then come back and we'll take a look at this. All right, so let me go ahead and do this. They give you the distance ratio to get to area. We're going to square both numbers. 3 squared is 9. 4 squared, 4 times 4 is 16. To go from distance to volume, we have to raise each number to the third power. 3 cubed is 27. 4 cubed is 64. So there's your answer for the first table. In the second table, they give you the area ratio, 16 to 81, so that's the area. How do we go back from a squared to a? We got to take the square root. So we're going to square root 16 and square root 81. The square root of 16 is 4. The square root of 81 is 9. How do we now go from the distance ratio? So we went back. Now we're going to go from distance to volume. So now to go from a to a cubed, we're going to raise each number to the third power. So that's going to be 4 to the third, which is 64. It's not 4 times 3, it's 4 times 4 times 4. And then it's 9 to the third, which is 729. And then the last one here, this time they give you the volume ratio. Let's go back to distance. So the way we go back to distance is we take the cube root of both numbers, and we will get 3 to 8. The cube root of 512 is 8. To go from distance to area, you're going to square both numbers, and you get 9 to 64. And that is the end of part 1.